Hello and welcome to the ASDRP Researcher Interview Series. Today I'll be talking with Adelina Chau. Thank you so much for being here this morning. How are you doing today?
I'm doing wonderful. How are you?
I'm doing great, thank you. To start us off, will you tell me a little bit about yourself? So what high school you go to, your hobbies, and anything else?
Yeah, so I'm Adelina. I'm currently a junior at Archbishop Mitty High School in San Jose, California. I enjoy all sorts of things specifically related to computer science. I do a bunch of coding projects on my own, specifically in machine learning, quantum computing, and those are all some of my interests that I actually continue pursuing at ASDRP with my research. And besides that, I also enjoy dancing, and in my own time, I'll just like free write when I have time. But yeah.
That's awesome. That's such a well-rounded number of activities. So was your interest in computer science what led you to finding out about ASDRP?
Yeah, so essentially before the summer of my freshman year, so basically like 2021, I got really interested in quantum computing. So essentially I was actually talking to some of my senior friends and they were talking to me about the things they were interested in computer science. And I actually met these people within my school's computer science club and I found out about quantum computing. So I spent the entire summer learning about this field. And then by the end of the summer, I was like, hey, it would be so cool if I could do some research in this field. So I went online, kind of searched to see where I could conduct research at. And then ASDRP was actually the first one that popped up. And I was going through the advisors and I was like, wow, I could actually conduct like real collegiate level research in quantum computing at ASDRP. So I sat down on my couch one day and I was like, I'm just going to get these essays done. And then I submitted it. And to my surprise, I actually got in. And that was really, really amazing.
That is so cool. Well, congratulations. I'm so excited that you're bringing your passion here. Um, that is so awesome. So how long have you been researching at ASDRP?
Well, I've been researching at ASDRP ever since fall 2021. So it's been about a year and a half by now. And I plan on continuing till the end of my senior year. So by then it'll probably be around 3 years. Yeah.
Great. You'll be a veteran researcher.
Yes. Mhm.
So what project group are you working with right now?
Yeah, so I'm in Dr. Larry McMahon's quantum physics group, and I specifically work in the quantum computing subgroup. And I'm actually one of the co-leaders for that group. And inside of that group, our main project has been working on quantum machine learning for drug discovery. So our most recent work is actually focusing on one specific quantum machine learning algorithm called the quantum generative adversarial network. And we've essentially been playing around with that to generate various molecules with the end goal of expanding current molecular drug databases. So that's kind of a bit about my current research at ASDRP.
Great. That sounds like such a cool project. Would you mind elaborating a little bit more on what it's like to do research in the quantum computing subgroup?
Yeah, so a lot of my research is computational. So I do a lot of work from home and I log onto the server. That's my main way of completing research. I would say a good chunk of my time is spent on reading previous papers on this field and then perusing like GitHub for code that other people have written. I would say that's my main like research time. That's where I spend a lot of my time. And then there's obviously the part where I actually implement these code or algorithms that I look through into our purposes. So I would say that's kind of how my research has been going. And then we also have like weekly meetings where I meet with my subgroup. And typically we would break down what the current state of our research is, look into what we want to set as our end goal for a specific week, and then we break up and then go about like addressing those goals. So that's kind of how I would say both of my researches and how our research is kind of broken up in our group. Yeah, that's kind of
Awesome. So with your team, do you mostly work by yourself or are there collaborative elements as you're like researching side by side with other people?
Yeah, so it typically depends on how many main tasks we have. So for example, let's say we have 2 main tasks and there's 6 people in our group, right? We would divide, probably 3 people are working on one subtask and then 3 people are working on another subtask. So typically that's how it works. So for example, right now I'm working with 2 other people on our actual algorithm for our research, and then we have another specific set of group who is working more on the data set part of our research, pre-processing it, finding more data for our model. So that's kind of how I'd say working and like collaboratively and individually, depending on what state of our research is.
That's super cool. What is the model that you're working on? Will you describe a little bit about that and just sort of how like the computational side of your research works?
Yeah, so we're working on a quantum generative adversarial network, and this machine learning model specifically super cool because it essentially has 2 models within it that are both competing to essentially outcompete each other. So there's something called the generator within the model, and there's also the discriminator. So the goal of the generator essentially is to generate images that mimic like real data. However, it's obviously like fake, but it's because it's generated. And then the goal of the discriminator is to get better and better and better at classifying whether these images or output that it's receiving from the generator is real or fake. And we just like essentially real is an image that comes from essentially a pre-given data set, and then the fake images would be images that the generator generated. So as you can kind of tell, the generator is actively trying to get better at generating these fake images, and then the discriminator is trying to actively work on becoming better and better and better at identifying these. So this, in a way, they're both kind of competing to outbeat each other, and in this competitive process, I would say they both get so much better, and that's how our model becomes a lot improved over time. So that's the quantum generative adversarial network, that model that we're using. And specifically, we're applying this to generating molecules. So the goal of this is within drug discovery, there's typically a lot of potential molecules that can be used for a specific drug. So when we were doing our literature reviews, you were like, hey, what if we could generate a model, like a quantum machine learning model, where if you tell the model, I want you to generate a subset of molecules that can have some specific chemical properties that we know in the past or it has been proven to essentially be effective for targeting a specific drug. If we are able to tell the model to do that, and it can generate a specific set of molecules that potentially do fulfill these criteria, it would make essentially the drug discovery process probably more efficient, because let's say when you go into the lab, you don't have to synthesize as many molecules because this machine learning model has already pre-processed and given you a set of molecules that potentially will work. So that was essentially the goal of our research, and we're applying this quantum generative adversarial network to that. So yeah.
Wow, that process is just so amazing. And it sounds like it must be really exciting to watch your model get better and better. And you said the discriminator, right? It gets like more sophisticated in generating these things.
Yeah, exactly. And I think it's really, really cool, specifically for our research, because a lot of our research is writing code, right? But after we train our model, we're actually able to pull our data and put it into a software called Avogadro, and essentially like model our molecules in like a visual form that's not just numbers and letters, because obviously that's a bit hard for us to visualize. So we have used a software called Avogadro to model it, and it's really, really cool when you're able to see that, hey, our molecules are getting a bit better each time. So initially, our molecules are one of our very first molecules were actually just like a bunch of atoms scattered around in a 3D space. And then a little bit later on, our molecule became a molecule where there was actually bonds between an atom. So there's one bond, and then slowly it became 2 bonds. So being able to see our model actually get better in like a visual form is very, very rewarding.
That's awesome. And that kind of leads right into my next question, which is what is your favorite thing about the research that you're currently doing?
Um, I think the favorite part of my research is definitely getting to see the molecule. So as a process that I just described, because a lot of times when we were writing the code, we ran into a lot of errors, especially like even getting our model to run, like took so much work and we ran into errors. Oh, like countless errors. Like we would solve one error and then suddenly we'd have like four more. And then after we get those four, there's like another 10. So the fact that we were able to get over that obstacle and then we actually had working data that we could plot out, I think that was very rewarding. So yeah.
That's awesome. It's so great to hear about the strides that you're making. And I'm curious, so I know that you mentioned you came into this project with like a lot of interest in the subject already, but was there any sort of learning curve like as you were working, and what was that like?
There were definitely a lot of learning curves because my group had previously worked on another quantum machine learning algorithm prior to this project, so they already had a lot of experience with quantum machine learning. However, I never really explored that on my own before coming into ASDRP. So a lot of my knowledge was like we learned as we go by reading through papers. And the generative adversarial network is arguably one of the harder machine learning algorithms because there's multiple models, right? So you have to learn like how each model works. And typically machine learning algorithms with just one model is like hard enough. So having to learn two of them and also apply quantum computing to it was really, really difficult. And I think another learning curve that I also had was our research kind of mixes into quantum chemistry as well. And I had not taken chemistry before coming into ASDRP. So I had to learn a lot of the terms like aromatic, acyclic, all of those like funny like chemistry terms that I've never had exposure to in the past. I had to learn a lot of that coming in. And I actually did a lot of work on the chemistry side of things too. So that was really, really interesting.
Well, that is so cool. So you have skills in so many different things.
Mhm.
And I bet that helped like in your actual chemistry class
Yeah,
a
for
little
sure.
bit. You're like, I'm way ahead of all of you.
Yeah, it's like I had to learn that on my own because I read a paper in the past and it had that in there. And now I'm actually learning it in class, so it was good. Yeah.
That's great. So because you're also working with chemistry, I'm just curious, is there any potential to work with another ASDRP project group in the future, like using your molecules and your data to help with their
Um,
project?
yes, exact. Actually, we've actually been working with the quantum chemistry group. Well, they were the quantum physics group in the past within Dr. like Larry McMahon's group. Now they're called quantum chemistry, but their group has focused on using Hartree-Fock to do a lot of approximations for ground state energies. So we're currently working on a collaboration with them to essentially, the goal is that we will generate molecules and then our molecules will be passed over to them and then they will perform a bunch of molecular calculations on it to essentially determine whether these molecules are feasible to actually be synthesized in lab, because obviously not every molecule can be generated in lab, even if it can be generated computationally. So that's our first step. And in the future, we would love to have a collaboration with a research group that works in person in the lab who will potentially generate or synthesize these molecules in the lab. So yeah.
Wow. I really hope to see that one day, just like the chain of researchers and just the way you all build on each other. That's so awesome.
Mhm.
Well, thank you so much for being here today. It has been such a pleasure to talk to you and get to know more about your project and machine learning. I've learned so much. Um, for my final question, I would love to know what advice you'd give to a future researcher looking to join ASCRP.
Yeah, so I think one of my main pieces of advice is do not be afraid to make mistakes, because this is like research is so open-ended and honestly no one knows the exact answer to any question. And I think coming into research I didn't really like know that. Well, I knew that, but I never really like understood what people meant by that, because obviously in school and like academic settings at like in a structured format, there's always like kind of a right answer, right? But in research, there isn't really a right answer, and that's why there's so many people working on trying to see whether things work out or not. So I would say the research process is a lot like trial and error based. And a lot of times you'll probably fail the first time, second time, third time, until like probably like countless numbers of times until you finally get one working model. And when you read papers, you get a bit intimidated by, oh wow, they did so many different like they accomplished so many different things, and why is none of mine working is like a huge question that you sometimes run into. But it's you have once you like think back to like maybe their research process, you realize that they probably tried a lot of different things as well, and finally they got to publish their research in a paper form. So I think that was the main piece of advice I would have loved to have coming into ASDRP, knowing what to expect, I guess, in the research process. And so that would be a key piece of advice I would give future researchers. Yeah.
That was perfect. That was such great advice.
Mm-hmm.
I hope the researcher watching this video, you can feel that and take that in to your research as well. Well, good luck in everything that you're doing. Good luck with your project in school. I can't wait to see where your project goes in the future. And thank you again for being here today.
Yeah, thank you. Bye.